This is 2007, I believe. Buick Rendezvous. Rendezvous. I say it that way because I know if I have to write it, I can spell it. Rendezvous. I say rendezvous, I won't be able to spell it when I'm writing it out. Okay? This vehicle here is in the shop for a sluggish transmission. It's in fail-safe mode. Okay? It's in fail-safe mode, and there's something that I found and I'm going to show you. Put this here. What they had was a mass airflow sensor code. It went to AutoZone here, and the code that they had for mass airflow was that P0102, or VAR air control low input. Okay, now this one was easy to find. That's not the only one that they had, but we're going to deal with this mass airflow. Let you see what I saw. Alright, I have this inside the history. Not sure if you can see that, but it had a P0753, a P0758, and a P2761. Torque converter, clutch, pressure control solenoid control circuit, shift solenoid control circuit. That's what? The 2-3 and the 1-2 shift solenoid. Okay. Then it had that mass airflow, which was P0102. Okay. That's for this 07 Buick Rendezvous. Here's what happened. The vehicle went to an oil change place. The customer wanted to get the oil changed, and they changed the air filter. When they changed the oil and the air filter, the customer had a check engine light that came on after she left. She went straight to AutoZone, saw that the mass airflow sensor code was present. So it didn't run right. Somewhere down the line, I guess that the transmission wasn't running right either. I don't know if it wasn't running right in the first place, or I don't know. But she has two problems. Well, the mass airflow sensor was simple to find if you look for something. It had a signal that was missing. She had it at a different shop. What they end up doing is changing the wheel bearings, according to what she said, hoping that would go away. But it didn't solve the problem. So now it's here. Again, I wasn't trying to fix the mass airflow. What I'm trying to do is deal with the transmission. Mass airflow goes to an engine diagnostic person. However, I find myself having to do that sometimes also. Well, here's what happened with the mass airflow sensor. As I was going into the wiring down here, which is here, I disconnected this. And if you see in here one, that connector is still in there. That's like a clip, I guess, to hold this in place, these prongs in place. It's stuck inside the mass airflow, this purple part. It can't come out. Do you see that pin right there that's bent back? You got 1, 2, 3, 4, and the other one is bent back. Okay, meaning it's not making connection. Now what I think happened is when they went to go and change the air filter, they pulled this out, they pulled the harness off, and that part stayed in there. Then when they went to go put it back in, because it wasn't lined up, it bent that pin down. Now you have a mass airflow sensor code, which is why when she left the air place, or the oil place, excuse me, that she had a mass airflow sensor code. So now this is just probably a matter, if it doesn't break, bending that pin back so you can get that purple part out. If that pin breaks, then you got to get another mass airflow sensor. It's just simple as that. Okay, so what I'm gonna do, let's see if I can bend that out, bend it back and then get it out. See, what it bent to the side, you can't even get this part out because it got it trapped in there. So let's see if I can get this out now. Now that's out. Take this and put it back. Okay, that's where it's supposed to be. Now if I got this straight enough, I should be... Yep, everything is fine. Now the pin is straight. That pin right there, so I can put that in. So that there is going to make her mass airflow sensor code go away. So she won't have to worry about this anymore. Now what I'm going to do is move this out of my way. See, this is how I found that, because I had to move it out the way too. And I'm always paying attention to things. You got to look at everything. So I got all of this wire apart. See, I had taken this apart, and the reason I got it apart, because I had to find where a break in the wire was for the control circuit for those solenoid codes. Now, it's highly unlikely when you get a code where it talks about 1-2 shift solenoid, 1-2, and it was the 1-2 and the 2-3 and the TCC, which are all on the same circuit, where all of them will be bad. Something that affects all of them will be the problem. Now I'm going to show you what the problem was. After peeling through this wire harness, here it is right there. That wire is broken. You see that? It's actually broken right there. That's the wire that goes to... Man, this thing don't want to turn. Let's see here. Alright, there you go. Where is that thing? There it is. It goes to that transmission case connector. It's the pink wire, you know, that goes to it. So, where are we? Right there. Alright, now the reason I have this here, because this is the great time to do a voltage drop test and show you how a voltage drop will actually work. I'm going to do it right on the bad wire, you know. And remember, a voltage drop test is to be done with the voltage on. So when I turn ignition on, there's supposed to be 12 volts going to this wire to power up the solenoids in there. Okay, 12 volts going to that wire. So I'm going to turn ignition on, but to verify, there's 12 volts on here. And I have this pin right here. Let me see if you can see that. There it goes. Why does this thing... Alright, this is a pin, safety pin, that's stuck inside this wire right here. This is the part that is good, where there should be 12 volts. This part won't have 12 volts on this side of it because it is broken right here. Okay, so let's see how a voltage drop test actually works. Okay, we're going to do one on a bad wire. Now, you're supposed to do this if you don't find the wire, so it can help you find what part of the wire is bad. Okay, so let me get my meter, then we're going to do this. Put it on the voltage scale. Alright, I don't have my clips because the leads for my clips are somewhere else. They're on a different car that I'm testing something else. Okay, so let's see what we could do here. Alright, on this voltage drop test here, the pin is here, it's on this wire right here, and it should be 12 volts here. So there won't be 12 volts on this side, okay, because this is broken, so it can't go over to here. So let's see. I'm going to take this pin here. Oh, maybe I still could use this by touching the inside of it. Okay, alright, I'm going to take this pin. You know what? I may have something else to use. Let me see. Alright, I do. I got a push pin here. Let me see. Let me push right inside this thing. I think that's it. Okay, so that's there. Now this pin is on the side where there shouldn't be any voltage because the brake is right here. This part should have the voltage, okay? Let me take this and put this on there. I can test the inside of that. Okay. Alright, so alright, let me see. Let me turn the ignition on. Alright, now I'm gonna, let me see if I can set this where you can see it too. So I'm going into here, and I gotta touch the ground. Alright, so you see 12 volts. Okay, so that's voltage going through that pink wire, 12 volts, which should be going to the solenoid. Now this side here is the same wire, but it's on the other side of the brake. And I'm touching ground, there's nothing there. Okay, so let me touch this one again, and you see 11.53 volts. Now when doing a voltage drop test, what you do, you touch this side, if I can get inside this thing. See there, do you see here? So there's 11.52 volts. What happened here? Okay, there was no voltage on this side when I went directly to a ground because it's not actually getting over there to it. But what is happening in a sense is the meter is almost like creating an alternative path for the voltage. Okay, so here is the brake right here, and I am actually on one side of the brake and on the other side of the brake. Okay, so once again, I do this meter and it bridges it almost as if that wire is connected, almost as if this is in good standing. But if this was in good standing, you know what I would see? I would see 0 or close to 0. Okay, So since that wire is broken, when I go to the other side of it and the broken part is in the middle, it's going to show 12 volts, okay? But it's showing 1150 12 volts, okay? So now the theory is that you should be able to find this broken wire if you can't see it by now moving one of these close to the other. So right now we know if this was a very long wire and it wasn't there and I was on that side, we would know that somewhere in the, where'd he go? Come here. Why did it disappear? Oh, okay, I fell out. Oh, there you go. Alright, you would know that somewhere in the middle there's a break somewhere in the wire. Why? Because with a voltage drop test, what you don't want is to see voltage through your meter. You know, there are words that is used that is hard, and it was hard for me to even understand this too. You're measuring the voltage potential. Now, what do you mean you're measuring the voltage potential? You're measuring the voltage potential. Potential voltage, so we got to use these terms that's going to throw us off. We are mechanics. We want to understand something that we can understand so we can get it over with. Okay, now you can use voltage potential and say that you are measuring what should be on the other side. So there should be 11.48 volts going to that side. It should potentially be 11.48 volts. If you want to use the voltage potential, you're measuring the voltage potential. But for those who want to keep it simple, here's what I'll tell you. When you do a voltage drop test, you don't want to see voltage in your meter. You understand that? You don't want to see any volts in your meter. It's that simple. If you see voltage, then you got a break. If you see, like right now, there's 11.4 volts, you shouldn't be seeing that. You should see 0 or close to 0. What, point something volts as they say it is. So let's see. If I'm going to go past this break here and go to the other side. Okay, the break is right here. We can see can we see that break? Let me see here. Let me get a light. Ooh, that's a good position. All right. So the break is right there, right here. So what I'm gonna do, I'm gonna take this off and put it on the other side of the break. I'm gonna take this one off, put it on the other side of this break. Okay, so take this off and I'm gonna put it on this side. Now what I have done, is the break in the wire is right here. Right here. Now what I've done, I've moved this pin from where the break was, it would have made it be in the middle, and put it on the same side as the other pin that didn't have the break. So in between the two pins there is no break. So let's see what happens now with the meter when I measure it. Okay, where did I do my... So I have that in there. Uh-oh, go back in there. Alright, so what do you see? You see nothing. Let me see on the meter. See? Nothing. Okay? So therefore, that's what you want to see. You don't want it, when you're doing a voltage drop test, you don't want to see any volts. Nothing on the meter. Okay, now let me make sure you can really see this, how I got that. Okay, all right, there's the break right there. That's the break right here. Okay, I have a needle on this side of it, and it was right here in this hole here. So as long as they were on the same side and not across each other, and the break in the middle, then if it's on this side, you will see 0 volts on your meter. If I put it on this side of it, where the break is in the middle, you will see 12 volts in your meter. Okay, let's see if I can do here. See, here's, see, oh wait a minute, there it is. You've got 12 volts. Okay, why? Because I have it on the meter on the opposite side. The break is in the middle. Okay, if I get on the same side and the break is on this side, then you will see 0 volts. Nothing. So here's the theory. If you got a break and you can't see it, if you way over here, see over here, and you, let's say you touch the wire here, you see 12 volts, you touch it here, you see 12 volts, you touch it here, you see 12 volts, you go here, you're going to see 12 volts. You keep bagging and bagging until you see 12 volts here because the break is there, but once you get on this side, the 12 volts goes away. See here, if I touch just this part right here, that's part of the wire that's open. If I look at the meter, you see that? It's showing 1135. Okay, now if I jump to this side and it shows 0 volts, and I go back over here and it shows 12 volts, I go back over here, it shows 0 volts, that means your break is right there. That's the voltage drop. That's what they mean when they say using the voltage drop. Okay, so now what I'm going to do to show you, I am going to stick this back on the same side of this one. It's going to show the zero volts. I'm going to put it back over here. Then I'm going to cut this part out. And it should show 12 volts because now there will be a break here. I'm doing this because this is easy for me to do and show you right now. Okay, so let me hook this up, put this back here. All right, I'm going to put this on the same side, and then I'm gonna cut the wire because I'm gonna repair this anyway. This was broken there, so I'm gonna repair this wire. So okay, now I'm gonna get a cutter because I'm gonna show you something. All right, I have to make sure that these things are making a good connection. And it looked like they were. Let me make sure once more. As you can see here, yep, I've touched the ground. Let me touch the ground on this one. Okay. All right, so gotta get this out where I can see it. Alright, so you should be able to see these here. Okay, right now these are not broken wires. The break is over here. So what's going to happen if I cut this right here? Right now the meter is reading 0, and this should have good connection. So the meter is reading 0. Let me show you. Put it down here. Okay. The meter is reading 0, and it's reading 0 because there is no break in the wire. The voltage is still going through the wire. Now what I'm going to do, I'm going to cut this right in between. And then we're going to look at that meter. Okay, now let's go over here to the meter and see if the meter does what it's supposed to do. Should show 12 volts over there. Show 0. Probably don't have a good connection somewhere. Should show 12. Let me see. Let me do this. It's not doing its job. Let me see. That should show 12 because it's cut. Why not? Why is it not showing 12? You know, I know what I'm going to do. That's okay. I'm going to put a jumper wire between this and then let it go so you can actually see it. Okay, now I got a jumper wire on here. If you can see that, I got a jumper wire here and down there. This is cut. The reason I have it that way so I can move this off and show you what I mean. Alright, so if you're looking at the meter down there, can you see that? No, it's hard to see. Ooh. Let's see. Alright, that might be better. If you're looking at the meter down there, if I touch this, it's going to show 0 volts, okay? So there's no break here. Okay, should be able to see the meter down there. It's 0 volts. Now, what I'm going to do, I am going to disconnect this, which means I'm just going to simply take this off, and then the meter should show 12 volts. See? If you looked at the meter showed 12 volts. This means the wire was broken. Or not 12, but 10.6 because I've had this battery on. If I hook it back up, it goes away. Okay? Come back. 12 volts. Now this is a broken wire right here. That's all this is a broken wire. This part here is going to the other side of the wire that was broken, and I'm going to connect these two wires together eventually. This is on the other part, that's on the other, and this part is on the other part. Okay, so again, if you're on this wire, if you see voltage on the wire, that means the break on this is in between here and in between here. Okay, so now I'm going to connect it together. The voltage should go away. See how it went away? Take it off, the voltage is there. So if you see, again, if you see voltage in your meter, that means you got a break when you're doing a voltage drop test. That's what a voltage drop test means. But if you use words like measuring the voltage potential, then you'll start to get messed up if you don't understand that. Now, like I said, the best way of understanding measuring voltage, or the words voltage potential, is potential voltage. Okay, what do you mean potential voltage? Well, let me hook this wire back up. When you disconnect, when this wire is broken and you see voltage through your meter, you're seeing the voltage that potentially is supposed to be on the other side of the wire. You can use it that way. It's potentially supposed to be on that other side of the wire, and if it's there, you won't see it. But since it's not there, then you see what should be there. Isn't that what potential mean? Potential? What should be there? So I guess we can use it that way. You're looking at what should be on the other side. So let's say that you only saw 4 volts. Well, 4 volts should be on the other side of the wire. It shouldn't be showing in your meter. If you saw 3 volts, 3 volts should be on the other side of the wire. It shouldn't be on your meter, okay? So we see 10 volts since it's a complete break. 10, well, in the case if the battery wasn't down, 12 volts should be going on the other side of this wire and shouldn't be in my meter. I hook this back up and it's not there anymore. So it is on the side that it's supposed to be. All right, so we understand that. Now, the thing about voltage drop, that's simple. The understanding of it is simple. The problem is, it won't always be this simple to get to wires. Sometimes you're going to have this wire in a dash. Just that little broken wire is going to be behind a dash, and you know what? You can't get your meters behind the dash. You're going to have to pull the dash out. Who want to do that? Okay? You don't want to do that. So you're going to have behind the dash, it might be under a seat, under carpet, inside door. You got to take the door panel out. You don't want to do all that. So in theory, voltage drop testing is good. You can find something. But as a practical practice, you probably won't want to do it. You would get a big long jumper wire and go from point A to point B and see if you get voltage. And if your jumper wire work, there's a break somewhere. Now, you may not go through tearing all of this wire harness out to try to find that. Okay? I will only go so far too before I'm going to look at the wire diagram, which is what I did anyway, but look at the wire diagram and see what I can bypass to get where I need to go. Is it spliced somewhere? Hoping that it's not. Because if it's not spliced, I'm going to look for point A, where it begins, and point B. And I'm going to run a different wire and be finished with it. But this is the voltage drop testing, okay? And now I'm going to repair this. Let me take this jumper out of the way. Okay, put this here, take this out of the way. So I'm going to repair this wire and put it together. And then when I put it together, then this is going to have its voltage to all of the 3 solenoids that's inside this transmission, and it should take off in first gear. Not right now, it's taking off sluggishly like in third gear. So it'll be finished. And the mass airflow sensor, you saw what was wrong with that. She won't have a problem with that. We was able to bend the pin back in this place and put it back in. So that's the end of this video, but I thought it might have been a very good video to show an actual voltage drop test on a circuit that is actually bad where you can see it. Okay, remember, you will do this when you really can't see the circuit and you don't know where it is. It's supposed to help you find the break.